So, hello everybody, and welcome to this month Patreon. It's a collaborative Patreon with Max Ruinger and me. Max Ruinger, designer at Man vs Machine, and a good friend. So we decided to make something together, and we did like a mirror board, and yeah. I think there will be a lot more to come in the future for you, or maybe more people. And yeah, we decided to take on sculptures, abstract, beautiful images with sculptures. So here's, for example, my sculpture that will be transferred to Max and will then do look dev for my sculpture. And I will give you now a really in-depth breakdown. Build that too, or something similar, course. And yeah, this is like the end result. Really quickly, I think. And let me walk you through. So in the middle, I got that brutalistic sculpture. Um, and yeah, it's basically out of blocks with different sizes, plus that metal framing around it, and those metal wires with pins holding it straight. It's two rings here that are like a little bit asymmetrical and rotated. And those rings are held by this liquefied abstract stone structure. And it's all sitting on like, yeah, a minimal desk or a podest, a stand, etc. You name it. So this is like the whole sculpture, and it's fully procedural. Toggle a few seats. Sculpture it'll will be different, and then anything else will adapt and like resim, for example, the stone if you want. Also getting different seats in there, and yeah, this is basically the whole thing. And started. So let me get a sip of tea here. And let's start. Um, I will break it down with like the brutalist sculpture first, then the connections, then the rings, then more organic sculpture, and after that the stand, which is pretty damn easy. Okay, for the brutalist sculpture, uh, we we start really simple. We start with a box. So what you can do, just place down a box and give it, yeah, dimensions. So this is then fully up to you. So for example, I'm going for like a more elongated form. I got 1 for 1 my size parameter. So to get it like more elongated shape. And after that, I want to create points from box. And there's an easy node, points from volume. And with that node, when you place it down, volume, you can really simply start to fill up your given bounding or your given geometry. And be a sphere, it can be a pig head, it can basically be what you want. So you can get a custom geometry here, and then for example dial down the point separation, play with the jitter seed, and get the jitter scale up, and got basically your volume filled points. After that, I did like the random selection. It's a lab node, so you just place it down. You get the ratio and randomize element order. So you can play with those, and then, for example, delete selected. So it will basically delete the selected points. So you can place it down, you can play with the seed, you can play with the ratio. You can make a group out of it if you want and then delete it. So yeah, that's basically fully up to you. And it's a pretty nice node. It's pretty handy and it's pretty fast. Also, if you are dealing with way larger. Then what I did, place down the attribute adjust vector. Also, like a really nice node. I think they introduced. Check that. And in 5 since when? Yeah, 18.5. I really like that node because I think you really get a lot of directability with this node in terms of vector adjustment, also float adjustment. So just placed it down and I changed the attribute name to n, so I want to manipulate basically normals. And the cool thing is what we can do with that node is and basically change our direction in specific values. So just set initial, random, and then specific values. And I want 6 specific values here from 0 to 5, pointing in minus direction, positive direction for each axis. And then you get something like this. So you get those really nice 90 angles. Of course, there are other ways to do that, but I think that's one of the fastest way to basically. After that, I will scatter some, basically some boxes. And I place this attribute up here, and you can see a few parameters. And when we dive in, you can see I created for each point number a seed. So it looks complex, but it's pretty damn easy. You of course can also do X, but I want to visualize it a little bit better. So for each point number, I want to create a different seed. So just add something point number and then random out of it, fit it. And then what I want to do, I want to multiply it with parameters. So those parameters are then used to multiply the scale attribute, not the p scale attribute. And the cool thing is with the scale attribute, what we can do then is play basically around with given seeds, of course, from each axis, and we can scale each axis. Of course, for example, the x-axis here, we can scale that, or we can make it wider and scale the y-axis. So I think, of course, p-scale is nice to get like a uniform random scale, but the scale attribute is also pretty cool and a little bit more art directable. And of course, simple copy to point. After that, I scaled each box a little bit. So just run a for each loop over each box with transform in here and set Android function, Android open brackets 0, 0, 1, and 0, 2. So this will translate the gizmo or your handle or your pivot to the center and that for each. And the cool thing is now you can scale it like. And after that, just place down the edge damage to get like a little bit more imperfection. So it will basically remesh the whole thing. And with this remeshing, it will introduce some edge. Do that, and here you can see it. It will also export a mask attribute and yeah, symbolize it. Marker here. Just toggle it on, and now you can see where basically the damage is introduced. And I think it's a really nice node to get like quick imperfection on something like that. After that, a material node, just material, and I also did it. Okay, then the framing is also pretty easy. What I did after the copy to points, we got a lot of boxes, of course, and with those boxes, can boolean them together to one uniform geometry. So just get the input each. So first input, same geometry. Second input, also the same geometry. Solid, solid, and then union. And you basically will merge the whole thing together. After that, convert line. And now you basically got like, yeah, the outline, the framing. Let's just merge them quickly together. Yeah, and now you can basically see it. Wait. With the offset, now you got like the framing from our initial sculpture. Now you can offset it. You can exclude maybe a few boxes where you don't want to have it with a last node. And after that, a resample, sweep, get them thickness, and I just wanted them together. And now we've got the cage. Merge that again together. We've got basically our sculpture caging, which is pretty cool. And now what I want to do, just show you that quick. Let's copy the whole tree here. And let's quickly hash that out, or let it recache the labs node. Nice. And now the cool thing is what you can do. You can go in here and get crazy. Of course, that will slow down the edge image hugely, and you can just play, for example, with a boolean. But what you could do, for example, is to get that on 15. And you've got this really, really long sculpture, or you can make it wider. It's also like kind of a greeble thing, which I pretty like. But yeah, you can now play around with that. You can play around with the seeds when you set them up. Points with the random selection. And yeah, I think you can get a pretty cool variety of like sculptures. And then yeah, let it run through. And then you have your first part of the artwork. What I did after that, you can already see while it's basically. I placed down a transform node because, of course, you can take it like that and be like really straight with things, but I wanted to like float it a little bit or hanging it in there. So yeah, I just transformed it a little bit. And what I also did, what I didn't I incorporated or included a little quaternion rotation with the axis from our normals and with a random degree cycle between -1 degree and 1 degree. And what that will do, it will introduce a little bit of imperfection. Now they are not perfectly in a 90-degree angle each other, which I pretty like. Of course, you can turn it off or you can go more crazy. -50 to 15 degrees. But yeah, that's of course. Then some normal nodes and same as output, not the final. And yeah, after that, I need to talk about the rings. Then, okay. What I wanted is like getting the whole thing, like a round edge or something that's it's like again in a framing. So of course we got like the individual concrete blocks with those wires around it, like a cage. But I want also like a cage for the overall thing. And yeah, that's what I here. Basically two cubes here. Just keep that reference. Two tubes around it, transform them a little bit. And what I did for them, again for each loop, Voronoi fracture, and I fracture them in several pieces, just together with like 5 pieces. And what I did again, I did another for each loop. And for each loop, I loop again over each now shattered or cut piece. And I just imported the iteration attribute and the other iteration attribute from the top loop. And this is running on primitives. And yeah, just created a random value, fitted it between 5 and 1, and extruded that as a random extrude attribute. And after that, I placed a poly extrude with the local control and inherited or imported and extrude here. So what we will have, we'll have a random extrusion. And yeah, then just create a group, the edges, poly beveled it, subdivided it, and do that 2 times. Part. Then I like imported the rings and I scattered some points of them and get those points ID attribute. What I also did from I excluded here the frame. What I also did is get that into here and I rate those points from the rings on my frame. Merge them both together and with the add, then just draw a polyline by attribute ID between those points. So between like between like the rings and the sculpture, and then put those. After that, yeah, I just run again for each loop, resample those, getting those twist. So twisted them a little bit, like 6 full twists, a little curve, so they are like a tiny bit thicker in the middle than on both ends. And then again, another sweep to get that thing volume. And all 8 pieces. And what I also did, polyframe. I looped for again over each line, and I extracted the centroid, so that's like the center point, and I imported that point, extracted it, bind it out to the normals, and what you then get is like smaller again. You get basically 2 vectors pointing to the middle on the line. Yeah, I copied then little tubes on there, so you can see each like copied to the line with the given direction of exported norm. I thickened those a little bit with poly extrude, get some groups in there, poly beveled them again, subdivided them, beat them, so they like merge together. Yep. In the end, merge that together and you got for actions. Which is pretty cool. After that, of course, I checked like a few times, will that look nice with framing? When we do like the framing with you can see there almost section, etc. Of course you can find that. But I really like that look. But pretty. Then what I did is like the part, and for the main part I grabbed my here, and what I did is converted or created a group and placed that on shared edges, and edge group to curve. I basically converted them into curves and then carved them. It's like not a full circle. Resampled them, and what I then did is like orient along curve. Getting the normals in here with the orient. Created a velocity VDB and imported that into a volume warp. What you also could do, you can get the velocity from curves, volume velocity from curves. Also nice, basically same job. So this is from an Axiom tutorial. It's pretty nice. Yeah, build it up and just search for on YouTube Axiom velocities. That will do the job. This tutorial will come up, and I just rebuilt that quickly. And it's basically like a more art directable setup. See, those are like the velocities that are created. But of course, if you don't have the time to build a volume warp, velocity from curves will basically do the same. But what you need to then maybe manipulate the input curve, which is also pretty fine. Yeah, this is like station, and this is basically 2 times. So 1 time for one time for the one direction and the other time for the direction. And I let like the solver here run. I second inside the what you also could of course use as a pop curve force. It should also work. And now you can see points basically traveling along those rings, and the other one basically the same but with -1 scale, so the negation on the normals, and it's basically the other direction. And let's dive inside. Nothing special, it's just a pop it vec by volumes, like higher velocity scale, so it will follow velocity faster. With trace and 0.8 on velocity blend and a pop wind, like a little bit more force, 2.5, and with a pretty high swirl size of 5 to just introduce a little bit of a more subtle imperfection. Of course, you can then play around with that and play around with offset, swirl size. So after that, time shifted that 2 times. So basically, I've froze the frame 240, merged that together, and now you can already see where this is going. I resampled that whole thing, so we got a lot of points here. Like okay, not that lot, 11 million points. And after that, what I did is create VDB from particles, so basically VDB. And this will cook a little bit, but yeah, you can see this is then the final VDB. And what I did, I like dilated a little, I eroded it a bit again. So those are like, I think, nice methods to just merge a few corners together and then again erode them. Then I need 2 more VDB. So one VDB is the ring with a pretty big dilation on it, and the other one are connectors, also with V-shape on it. So combined those two together, then basically subtracted them, or SDF different them from the final VDB. So what you can see that the rings will create holes here, and we got also holes for the connectors, so they're like not clipping through the whole thing, so that they are basically nicely added. Find a connect, like here for example. And yes, and after that I will again maybe combine it, fact box that I will use then for, and after that converted it and measured the whole thing for the curvature. That's like the curvature. So curvature measure node on points, measuring the curvature, width 1, attribute name curvature, and then you just bake visualized range into output. And the cool thing is you can directly remap it from 0 to 1, so that you later in the shading process got a nice ramp to work with. And what I also did is I just attribute. Then again, here is this box. And what I did with that box, beveled it again. Yeah, this is like basically the standing. And with everything coming together, get like that. And yeah, the cool thing is you can then play around with sculpture in the middle, with rings, with connectors, simulation around rings, and it always update. After that, I of course place for Max because he will do the look dev on mine, and I will look dev on from his sculpture. Place the background, and of course he will not get my lights, etc. that I used for my little look dev. And yeah, a background, sculpture, and then place the cameras. But I think he will camera. And what I also did, I just named everything accordingly. I think that's important in workflow like that. Also, if you are on commercial projects and you need to shift files around, I think this is. And yeah, those are basically the outs. Got main shape, got the rings, the connectors, fluid stone, and base stand. And then given heavy geometry visual link for redshift, those are those three. The connectors are separated in two, so you got the little connectors and you got the wires. And of course the main structure also separated in the concrete and in the connection, or basically the wireframe around. And then you got the out final node. Yeah, so this was the in-depth breakdown. I hope you liked it, and I will see you in the next part, and we will do some look dev on the sculpture X.